Hi everyone, my name is Gabriela and my presentation is about digital rock analysis based on X-ray computer tomography of pre-salt lacustrine carbonate reservoir from Santos Basin, Brazil. We know that carbonates have a very heterogeneous pore network, which makes the multi-scale study very challenging. In this context, the X-ray computer tomography has gained usage for reservoir characterization. The objective of these studies is to explore the computer tomography images, that is a non-destructive technique, which is possible to calculate the porosity, segment the mineral phases, and also visualize and characterize the pore network. Uh, this work expects to contribute to future works involving rock types and multi-scale characterization. In this presentation, we are going to go over to the results obtained from the CT image processing. The studied area is located in the Santos Basin, focusing on the Barra Velha Formation, an important pre-salt reservoir. The samples studied here are from the well composed mainly by reworked carbonates, and they represent the top of the Barra Velha Formation. The petrological and petrophysical analyses were conducted on 12 plugs and approximately 14 meters of the core from Barra Velha Formation. The applied methods here include optical petrography, X-ray computer tomography, and conventional boroperm gas tests. With the X-ray computer tomography image acquisition of the core and plugs, the next steps was the image processing, where the images are subjected to filtering and segmentation. After we got the processed image, we obtained the total porosity of the core and plugs, and we also obtained the effective porosity and petrological segmentations of the plugs. In the next steps, we performed the pore network modeling, again only on plugs. This is an important process which revealed us data such as the pore and throat size, coordination number, pore and throat geometry, and distributions of pore and throats. Now I'm going to show our results starting with petrological analysis. And the variations in shades of grays was analyzed in the slices to identify areas of different materials. The plugs studied were segmented into three mineral phases, and here in this picture we showed it. We have carbonate phase, undefined phase. The undefined phase can be composed of microporosity, cement, or a combination of both. The boundary between the microporosity and cementation is subtle, and due to the image resolution and also the similar attenuation coefficient between quartz, calcite, and dolomite, it was not possible to differentiate the components of the undefined phase. The microporosity is represented mainly by intraparticle and intracrystalline porosity. And here we have dense minerals. The CT allowed the clear identification because these minerals appears as a bright spot on the tomographic image. And here we have the porous phase that is used for the petrophysical analysis. And now in the petrophysical analysis, we obtain some results. The porosity estimated here by the high resolution CT scan ranging from 7.5 to 12.5%. Even in a high resolution, the CT scan porosity of the plugs was underestimated compared to the gas porosity. Apart from the porosity analysis carried out by the software, many relationships could be established with the studies of the pore network modeling, or also PNM. In the PNM is an important tool because it helps to obtain a lot of information, as I said before, such as the pore and throat size, coordination number, and we can visualize the distributions of pore and throats in each sample. In this picture here, in these histograms, we have the the frequency of pore and throat obtained from the PNM for each sample. When we look in the first picture here, related to all pores in the sample, we can notice a bimodal distribution with a peak frequency of smaller pores. When we compare total and effective pores, the two distributions suggest that effective porosity is dominated by larger pores because we observe a great decrease in peak frequency of smaller pores and showing now a unimodal distribution. Now, throat radii, both in relation to total and effect porosity, exhibit unimodality, showing a decrease in frequency peaks, but no measured change in their peaks when compared total and effect porosity. In this picture here, we show another result related to the relationship between coordination number and pore radii. The coordination number is an important parameter of the pore network, which refers to the number of throats connected to a given pore. Is related to the connectivity of the samples. And this chart shows the positive correlation between the coordination number and pore radii, indicating a tendency for greater pores to be connected to more throats. And now in this chart, we show the relationship between the gas permeability and porosity. The plugs was divided into three groups according to permeability values, and fair, good, and very good permeability. And we observe that there is a poor correlation between phases and petrophysical properties because we reworked lithologies and shrubstones in groups classified in very good and fair permeability. And the important factor that needed to be considered is the type of porosity control. The samples here classified as very good permeability has dominant depositional porosity control. The samples here is not affected by the cementation. And another result was the CT scans of the core, which was able to segment and calculate the porosity that ranged in each interval between 1 and 5%. It's lower than the CT of the plugs because of the limit of resolution. The vertical profile is characterized by high porosity peaks that are a few centimeters thick, intercalated with low porosity zones. Of porosity are usually linked with intraclastic redstone lithology and shrub-dominated lithology that happens when depositional control is dominant. The combinations of different scales is important for a better understanding of the pore system. It is also possible to associate the porosity with the lithology or diagenetic process that occurs in the core interval. The intercalation here in this picture, we have the intercalation between reworked carbonate and also shrubstones layer, and we can see that we have a peak frequency linked to a shrubstones layer, that we have a growth framework porosity as we can see in the plug and also in the thin section. And this part here, we have a reworked carbonate that is intensely affected by the cementation, and the porosity here is compromised. And some conclusions of this work, the CT scan analysis provide important information on mineral segmented phase for network parameters and total and effect porosity results estimated from the image segmentation. The mineral segmentation was split into three mineral phases: carbonate, undefined, and dense minerals. Analysis with PNM data revealed important information on fabric characteristics that total and effect porosity distribution, and also pore and throat size and coordination number. The combinations of different scales, core, plug, and thin sections is important for a better understanding of the pore system. Furthermore, it is possible to associate it with the lithology or diagenetic process that occurs in the core interval. And that's it. Thank you.